In this video, we're going to try to classify a triangle that is shown in a coordinate plane. By classify, I mean name it in this section and name it in this section. So remember, isosceles and isosceles triangle means that there are two sides the same. Scalene means no sides are the same length. Equilateral, or you could call it equiangular, all the sides are the same. A right triangle, of course, has a 90-degree angle. Acute means all the angles are less than 90. They can't equal 90, it has to be 89 or whatever. And obtuse is greater than 90. All right, so here we have a triangle. Well, you know, it kind of looks maybe like it's isosceles, but there's no way to know yet. The only way you can find out is by two things. One, to find out if it's acute, obtuse, or one of these, you have to find the slope. You have to do the slope. For this, to find out if it's isosceles, scalene, or equilateral, you have to use the distance formula because you've got to find out how long each side is. Okay? All right, so we're going to, let's figure out the distance from here to here. Let's call that A, B, C. All right, so A, B, -1. I'm just going to do the distance formula right here. The distance formula is on the wall in our room, by the way. X minus x squared plus y minus y squared. Okay. So I have x here, so I'm going to go -1 minus 6 squared plus 2 minus 3 squared. All right, now that's going to be -7 squared is 49. This is 2 take away 3 is -1. -1 squared is 1. So this first answer is radical 50. And I'm not even going to worry about reducing that for right now. All right, so that's from A to B. Okay, now let's go from C to B. From C to B, it's going to be 0 take away 6 squared plus 0 take away 3 squared. And let's see what that's going to be. So -6 squared is 36 plus 3 squared is 9. So that's, and by the way, these are all under the radical, hello. So this is what, 45? So this is radical 45. So from C to B is radical 45. Now, you know, the truth is, you really don't have to do this third line because you know it's not, you know, we're trying to figure out if these two guys are the same length. And you can tell by looking that they weren't. So right now, we know this is a scalene triangle. All three sides are different. So that we know. Now we have to figure out if it's a right angle or if it's a right triangle or, you know, acute or obtuse. All right. So we can try to determine the slope of each one of these lines. So let's figure out the slope of AB. AB, A to B. All right, the point is -1, 2, and this was 6, 3. All right, to figure out the slope, we take y2, take away y1, divided by x2 minus x1, which is -1, like that. Okay, so this is going to be 3 take away 2 is 1, 6. Remember, this turns into a big fat plus. Plus 1 is 7. So the slope of AB is 1/7. All right. Well, what about the slope of CB? All right, C to B, the point is 0, 0, and it goes to 6, 3. All right, so 3 minus 0 divided by 6 minus 0 equals 3/6 is just 1/2. So this is, here we have 1/7, here we have 1/2. Okay, well, those slopes aren't the same. Let's do AC. So for AC, it is -1, 2, and 0, 0. Okay? Okay, 0 minus 2 divided by 0 minus -1. And that just equals -2 over +1, which really just equals -2. All right. Now, anybody have an idea? What do we call slopes that look like that? 1/2 and -2. By the way, isn't that -2/1? Remember, this is the negative reciprocal of that. Not because it's negative, but just because the sign has changed. So I have 1/2 and I have -2. Therefore, the lines are perpendicular. That means that they meet at right angles. That means that this is a right triangle. So our two answers are, it's a scalene right triangle. This picture is a scalene right triangle, and the right triangle occurs right here because this line and this line are perpendicular. Okay? So when you're trying to classify a triangle in the coordinate plane, you have to use the two distances, at least two of the distances, unless it looks like it might be isosceles, or equilateral, excuse me. If it looks like it has to be equilateral, then you have to do the distance for every single line. But then you have to figure out if it's a right triangle or not. In another lesson, I'm going to show you how to find out if it's obtuse or acute.